Hi everybody, this is Dr. Hamid with your College Mathematics 120 class. Today we'll talk about irrational numbers, okay, which is section 5.4. In section 5.3 we talked about rational numbers, okay, and now we'll talk about irrational numbers. So let's get started. Now in today's section 5.4 we will talk about irrational numbers. We'll define irrational numbers, okay, we'll give examples of irrational numbers, we'll see how to distinguish between a rational and an irrational number. We will learn how to deal with the square roots, okay, square roots, simplify square roots, combine square roots, do other operations involving square roots, and how to rationalize the denominator. Okay, so these are our main goals, main objectives in this section. So let's start with the irrational number. Okay, irrational number is the set of numbers whose decimal representation it neither terminate nor repeat. Okay, so it just goes on and on and on and on and on. Okay, it does not repeat. It does not have a specific pattern like 0.63636363, or and it does not terminate like 1/2 terminates 0.5. That's it. Okay, so these are those numbers. If we write them in a decimal representation, they do not terminate and they do not repeat. Okay, so it's the third category. Now, a very famous irrational number is pi. Okay, which is if you write it as a ratio of two numbers, it's 22/7. Other things, but we call it pi because the numerical value of pi in decimals, it goes on when we write it in the decimal place. Okay, it does not repeat and it does not end. Okay, if you recall pi, I remember just 3.1415, but it goes on and on and on and on and on. Okay, and similarly another example is square root of 2. Okay, square root of 2, it never ends. It goes on and on and on and on, and it is a how you call it, it's not repeating, it's not terminating. Okay, so both of these are irrational numbers. Okay, uh, now since most of the irrational numbers are square root of integers, so let's talk about that. uh, the principal square root of a non-negative number n, we write it as like this one. Okay, this is the symbol of the square root and the number in there which we represent n. This is a positive number, and that when we multiply it with itself, okay, it produces what we are taking the square root of. Okay, for example, the square root of 36 is 6. Why? Because if you multiply 6 with itself, it will produce 36 right there. Okay, now note that square root of 36 is a rational number, not irrational, but it's a rational number because 6 is terminating. Okay, now square root of numbers that are not perfect square, like this 36 here, okay, some are not perfect square, they are irrational numbers. For example, square root of 3, this is irrational. Okay, so square root of numbers that are not perfect square will produce irrational numbers. Now let's see how to deal with the a little bit more about square roots. A perfect square, okay, is a number that is a square of a whole number. For example, okay, here are few perfect squares. Now 1 is a perfect square of 1. Okay, if you take a square of 2, you get 4. So 4 is a perfect square of 2. If you multiply 3 with itself, okay, it will give you 9. So 9 is a perfect square of 3. Okay, so the square root of a perfect square is a whole number. That's the bottom line here. Okay, so if you take the square root of this, okay, 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So going back to this statement, the square root of a perfect square, okay, is a whole number. So 1, 4, 9, 16, 25, they are all perfect squares, and if you take the square root of that, you will get a whole number, not a decimal or anything, just a whole number. Now let's talk about product rule of square roots. Now we are getting into the business of how to simplify square roots, okay, the quantities involving square roots. Suppose that you have two numbers, okay, a and b. Okay, they represent non-negative numbers. Remember that nothing negative can go into the square root. That's why I have this condition of non-negative. Okay, so non-negative means it can have 0, okay, but a 0 and more. Okay, so a and b represent non-negative numbers. Then the square root of a times b is same as square root of a times square root of b. Okay, so if it is multiplication, square root of multiplication is same as multiplication of the square roots, or the other way around. Okay, you can go from this here to here or here to here. Okay, so now in words, the square root of a product is the product of the square roots. Okay, this tool is very helpful when you simplify square roots. If you have a product and the square root of the whole thing, you can sort of separate them. Okay, or if it is given in a separated form, you can combine them under one square root. Okay, now how to simplify square roots? To simplify square roots, what we will do is we will basically find a number which is a perfect square of something. Okay, so that will be our goal. Suppose you want to simplify square root of 75, okay, and square root of 500. So we'll see how to do it. Now 75, can we not write 75 as a product of 25 times 3 here? Okay, now using the property I defined in the previous slide, we can separate them, write it into two square roots. So one is square root of 25, other one is square root of 3. Okay, nothing we can do with square root of 3 here. Okay, it's not a perfect square of anything, but 25 is a perfect square of 5. So the square root disappears there. So we have 5 square root of 3 there. Okay, similarly in this one here we can write it as 100 times 5. Okay, again separate the square roots and we get 10 into square root of 5 there. Okay, now let's look at one example. Suppose we have square root